This video is going to cover the chapter review and the extra area that was due this morning at 8 a.m. So the first question you needed to answer was to identify the apothem of the square, and the apothem of the square is segment XZ. Then it says to identify, and that's right here. And then it says to identify the radius of the square, and I'll do that in blue. And that's going to be XY. The next question is asking you to find the diameter of the circle. So they're giving us the circumference. So recall that the formula for circumference, we can, since they're asking for the diameter, we're going to use pi d. It's asking us to use 3.14 for pi. So I'm going to replace the value of the circumference, which is 94.24. I'm going to replace pi with 3.14 and leave the variable d, which is my diameter. In order to find the length of the diameter, I'm going to divide both sides by 3.14. And that tells me that when I divide that, I'm going to get 30.01 is equal to d. Next question, number 6. It's asking me to find the circumference. So they're giving us the arc measure and the measure of the arc. So this formula I'm going to use is arc length is equal to the measure of the arc divided by 360 times the circumference. So the length of the arc is 5.5. The measure of the arc is 35. And I'm going to leave the circumference as C because that's what they're asking me to find. So in order to solve for this, I need to get C by itself. So I could either multiply by the reciprocal, or if you want to show it step by step, multiply both sides by 360. And then 360 times 5.5 is 1980. And now I'm left with 35C. Divide both sides by 35. And your circumference is equal to 56.57 centimeters. Over here, my diameter on this one, these were feet. Go ahead and look at number 7. Number 7, they're asking us to find the length of GH. So again, I'm going to use the arc length. Is equal to the measure of the arc over 360. And now I'm going to multiply it now instead of just a C, 2 pi r. So again, we're solving for the length of the arc. We'll call that L. The measurement of the arc is 115 over 360 times 2 times pi. And my radius length is 13. So I could go ahead and I could simplify my fraction. And I could reduce this to 23 over 72, 2 pi times 13. I could simplify the 2 and the 72, make it 36, and then now multiply what remains. So 23 times 13 is 299 over 36. These are pi inches. It said to keep it in terms of pi. For number 8, 8 and 9, we're going to keep it in terms of pi. Actually, all three. We're leaving all three in terms of pi. So let's do number 8. So here it wants the area of the shaded region. So if you recall, the formula for area of the shaded region is we're going to take the area, so this will be area of a sector. So the measurement of the arc over 360 times the area formula, pi r squared. So let's go ahead and for number 8, let's replace what we know. So we're going to do area of the sector is equal to 240 over 360 times pi times 9 squared. So let me go ahead. I could simplify these, and then I could also reduce 24 over 36 into 2/3. I can square the 9, make it 81. And then I could simplify the 3 and the 81, change that to a 27. So final answer here is 54 pi inches squared. For number 9, again, it wants the area of the shaded region. So what I'm going to do first is I'm going to find the area of the rectangle, and then I'm going to subtract out area of half the circle. So I'm going to subtract out half of the circle or the semicircle area. So for area of a rectangle, remember it's base times height or length times width. So I'm going to do 4 times 6. And then for my circle, they gave me a diameter here of 4. So I'll turn it into a radius of 2. So 2 and 2. So again, for this, I'm going to do area of a circle is pi r squared. So 1/2 pi times radius squared. So 24 minus 2 squared. I can make this 4, but then half of 4 is 2. So 24 minus 2 pi, and this is inches squared. And that's number 9. Number 10. They've already calculated the area of the sector for me, and they told me that the area of that sector is 5 pi. Now, what I don't know is the length of the radius. So for number 10, we're going to use the formula for area of a sector. So again, remember it's the area of the sector is equal to the measure of the arc over 360 times pi r squared. So the area of the sector is 5 pi. The measure of my arc is 50. And I'm going to leave the pi r squared. So the first thing I'm going to do is I'm going to calculate and figure out how long my radius is. So first thing I could do is I could simplify this. I'm left with 5 pi equals 5 over 36 pi. I could divide both sides by pi. So it cancels on both sides. So now I'm left with 5 is equal to 5 over 36 radius squared. I can multiply both sides by the reciprocal, or divide both sides. Either way, or you could do it step by step. So notice these cancel. I'm left with radius squared. This cancels. I'm left with 36. Square root it. My radius is 6. Now that I found the length of the radius, Now I can go back and find the measurement of the arc, or I'm sorry, the measurement of the area of the blue sector. So remember, there's 360 degrees in a circle. So up here, if you do 360 minus 50, I know that what's left here is 310 for the blue. So I'm going to do 310 over 360 times pi r squared. And again, my radius is 6. So I could simplify the zeros. 31 over 36 times pi times 36. The 36's cancel. So the area of my sector is 31 pi. And these were centimeters squared. And that's number 10. Let's take a look at number 11. 11 says a platter is in the shape of a regular octagon. Find the perimeter and the area of the platter if its apothem is 6 inches. So let's go ahead and let me do number 11 over here. So it says it's an octagon. Let me try to draw an octagon here. So 1, 2, 3, 4, 5, 6, 7, 8. And it told me my length of my apothem is going to be, just draw that down here. And it says the length of the apothem is 6 inches. So for here, what I need to do is find the measure of my central angle. So I would take 360 and divide it by 8. So my central angle is 45. What I'm going to do is split my apothem here. And what I'm going to do is, if this central angle up here at the top is 45, when I split it, it becomes 22.5. Remember, when you're trying to find the area of a polygon, and if it's not a hexagon, an equilateral triangle, or a square, we have to use our trig. We have to use SOHCAHTOA. So already I know that I've split this into 2 isosceles triangle. So I know the length here. I know my apothem is 6. I need to figure out how long my side length is. I need to find this side here. So in relation to the 22.5, this is going to be opposite, and this is going to be adjacent. So I'm going to be doing tangent of 22.5 is equal to x over 6. I'll multiply both sides by 6. And I end up with x is equal to 2.485. And I'm going to double that, times it by 2. Because remember, when I pulled it out, there was 2 pieces here. This was x and this was x. So the length of my side length is going to be 4.97. So now I have all the pieces I need to calculate perimeter. Remember, it's the number of sides times side length. So an octagon has 8 sides. So 8 times 4.97, and that's going to give me 39.76. I'll round it to the tenths place, 39.8. That will be the perimeter. And now to find the area, I can do 2 things. I could either do 1/2 ANS or 1/2 A times perimeter, since I've already calculated it. So if I just use this formula, 1/2, my apothem was 6, my number of sides is 8, and my side length is 4.97. Once I multiply these four numbers, my area is 119.3 inches squared. Let's do number 12. Number 12 says that we have a regular pentagon. Do it over here. So 1, 2, 3, 4, 5. And in this problem, they told us that the radius length was 17. And they also gave us the side length, and they told us the side length was 20. So let's drop down our apothem. Now, remember when we drop down that apothem, it's going to split this into 10 and 10. So to find the length of the apothem, I could do Pythagorean theorem. So I'm going to do 10 squared plus apothem squared equals 17 squared. 100 plus apothem squared, 289. Subtract 100 from both sides. A squared equals 189. I'll square root that. And A is equal to 13.7. So for number 12, all it asked for was the area. So area equals A and S, 1/2. So 1/2 the apothem times the number of sides, which is 5, times the side length, which is 20. So my area is equal to 685 centimeters squared. Now there's a few questions that are typed in here that weren't from the textbook, because remember we supplemented the lesson with some extra material. Of the blue is going to be 5/2 pi. So now I need to find the area of half of the circle. So again, my circle is pi r squared, but it's half of that. So half of 36 pi, change that to 18. So it's 18 pi. So now I have area of the blue, 5/2 pi, divided by 18 pi. I can do a keep flip change here, and I'm going to do 5/2 pi times the reciprocal, so 1/18 pi. And you can see that the pi's will cancel, and then I get 5/36. You can divide that, so you can leave it as a fraction, or remember you can make it a decimal, 1.388, or make it a percent, 13.9%. Either way. Let's try number 15. So it's okay leaving it as a fraction. I would leave it as a fraction. So for number 15, we need to find the area of the triangle. And then here, it's going to be area of half of the circle plus area of the triangle. Because it's the whole thing. So for area of the triangle, we need to figure out, so we can see that it's going to be base times height divided by 2. So the triangle is 1/2 base times height. And then down here, half of the circle, we can see that the radius here if I take half of 6, which is the diameter, the radius is 3. So 1/2 3 squared pi, that's the circle, plus the triangle. So if I multiply, this is actually equal to 45, so plus 45. So I now have 45, and then this is going to become 9 pi over 2 plus 45. So if it says leave it exact, we would leave it like that. If we were to use our calculator, actually we could divide this. Let's see, so let's go ahead and just use our calculator, and it's about 76.1%. And then number 16, we're going to have area of the rectangle, which is here. Then we're going to add area of the half of the circle, which is here. And then over the whole thing, which is area of the square. So we could see area of the square is just going to be 4 times 4. Area of the rectangle, we're going to do 2 times 4. This will be split. So 2 times 4 is the rectangle. And then the square has a diameter of 4, so 2 and 2. So the radius is 2. So we're going to do plus 1/2 pi r squared. To change that to a 4, take half of 4 and it's 2. So now we have 8 plus 2 pi over 16. And then I can simplify. I could divide everything by 2. Make that a 4, make that a 1, make that an 8. So 4 plus pi over 8. And you're done. And then the last part are the extra areas. So a triangle with side lengths 3, 4, and 5. This is actually a right triangle. This is a triple. Remember, the hypotenuse is always the biggest side. Remember, formula for area of a triangle is 1/2 base times height. So 1/2, 3 times 4, and this will give me 6 units squared. A rhombus with diagonals 4 and 6. Remember, the formula is 1/2 diagonal 1 times diagonal 2. So 1/2, 4 times 6, and it gives me 12 units squared. An isosceles triangle, 10, 10, 16. I need a height. So let me go ahead and draw down my height. It'll split this into 8 and 8. You should realize that this is a scaled up triple. If not, you would pull this out and do Pythagorean theorem here. 8, 10. So this is actually a 6, 8, 10. So now my height is 6. My base is 16. So 1/2 base times height, and it's 48 units squared. Another isosceles triangle. This time it's got a 10. I'm going to take 36 because they told me the entire perimeter. Subtract the 10. Remember that these two sides are congruent, so divide this by 2. So each of these are 13. So again, here is my right angle. So again, it splits it. So again, I've got another triple. So 5, 13, and then this one's going to be 12. Again, if you do not know your triples, you would have to do a squared plus b squared equals c squared. So now that I have the height, it's 12. My base was 10. 1/2 base times height, and I get 60 units squared. an equilateral triangle with a perimeter of 18. So if I draw my equilateral triangle, 6, 6, 6, and then drop down my apothem, or my height. Remember, this is equiangular also. So if I just work with this, 30, 60, 90. And again, across from the 30 is x. The hypotenuse is 2x, and this is x root 3. So if I know that this gets split, so x equals 3, so then my height is going to be 3 root 3. So 1/2 base times height. So again, my base is 6. My height is 3 root 3. So 1/2, 6, 3 root 3, take half of 6, and my final area here is going to be 9 square root 3 units squared. Next question is a rectangle with length 16 inscribed a circle with a radius of 10. So I have my rectangle here, and then it's inscribed in a circle. And it's got a radius length of 10. So if the radius is 10, and then it says it has a length of 16, put 16 here. So I could also extend over here and say this is also 10. So now realize that we've got a right triangle here. So now we could do Pythagorean theorem. I could pull this out. So this is 16, this is going to be 20, and I need to find this side. So this x is actually going to be the width. So x squared plus 20 squared, no, plus 16 squared, 20 is the hypotenuse. X squared is x squared plus 256 equals 400. Subtract 256 from both sides. X squared equals 144. Square root it. X, or my width, is 12. So now all I have to do, area of a rectangle is length times width, or base times height. So 12 times 16. And the area of the rectangle is 129 units squared. For number 7, area of parallelogram is just base times height, so 28 times 32, and I'm going to get 896 units squared. Number 8, an isosceles trapezoid. So let me go ahead and draw one. So because it's isosceles, these two legs are the same. My smaller base is 10. Each of the legs are 30 square root 3. Told me that the base angles here are 30. So what I'm going to do is I'm going to split this up because I need to find the height, because the formula for an isosceles trapezoid is 1/2 height, base 1 plus base 2. Make sure you know this formula. So I need to find the height, and I need to find base 2. So what I'm going to do is I'm going to work with one of these right triangles here on the side. They're both the same, 30, 60. So I already know that across from 30 is x, across from 60 is x root 3, and over here, this is 2x. So I need to solve for x. So 2x equals 30 root 3, divide by 2, and x is equal to 15 square root 3. So that's going to be my height. Then over here, to find this little piece and this little piece, I'm going to do 15 square root 3, which is x, and then I still have root 3. So 15 times 3, and that little piece is going to be 45. So now, my base 2, which is down here, is made up of 45 plus 10 plus 45. The height that we found was 15 root 2. So I'm going to plug it into this formula right here. So 1/2 the height, which is going to be 15 root 3. Base 1 is 10. Base 2 is 100, because I'm going to add 45, 45, and 10. And I get 100. So 1/2, 15 square root 3 times 110. So then now I'll multiply it. So I could take half of 110, it's 55. So 55 times 15 square root 3. And I get 825 square root 3 units squared. Last question. It's this house-looking shape. So what I'm going to do is I'm going to find the area. I'm going to divide this up, and I'm going to find the area of the triangle top and the rectangle bottom. The rectangle bottom is just 4 times 8, so the rectangle is going to be 32. Then for the triangle, notice it's isosceles. So if I drop down and try to find my height, when I split the 8, this becomes a 4 and a 4, and again, this is a triple. So the area of the triangle is going to be 1/2 base, which is 8, height, which is 3. 1/2 8 times 3 is going to be 12. So 32 plus 12 gives me 44 units squared. And that's the end of your review for the quiz tomorrow. So make sure you have all of your formulas written down so you have quick reference for them. You can use your calculator, and you can use whatever notes you want to use. So I'll see you tomorrow on our Zoom call, and we'll be taking the quiz. The quiz is 30 minutes. Remember to watch your time. Remember to show work for all of the questions. You must show work for everything to get full credit.